So when you open up your brine tank, there'll be what we call an inner brine well. This is a 4-inch plastic tube, and this holds what's called the brine safety valve. This particular brine safety valve allows water to come in and out of the tank via this check valve in the bottom. It also has a float here, so that way if it does overfill, that float will shut the water off and won't overflow the tank. So that's another feature of this. Now typically when I install these, I'm going to spin this tank so you can see here in the shot, but there's an overflow here. You always want to make sure this float is below that overflow. So if you can imagine where it is now, it's quite a bit below it. I'm going to move this one up because for this particular unit, not the one we're installing, but the one that it's going to ship with, is a 3 cubic foot unit. So we want to make sure we can get enough water in this tank before this float shuts off. So to lift the float up is pretty simple. You're just going to push these actual washers down, and then we can kind of somewhat see where we're at again, because that's the hole, and it's just below there. That ought to be about perfect. Okay, now with that being said, we have to cut off this excess rod. I'm going to do that now. Now once you've cut this off, it doesn't really matter what size tanks you have. You just want this float to be just below that overflow barb. So if you cut it off and you're below the overflow barb but the water never comes anywhere close to there, that's fine. Again, this is not part of normal operation. This is just a safety mechanism so this tank doesn't overflow. Now once you have that adjusted, we're going to take the securing nut off the back here. We're going to put it back in the tube, and then this particular threaded portion is going to go through the hole in the side of the actual brine well. And then we take our securing nut, and that'll tighten it down and hold it in place inside the brine well. Just snug it up a little bit. Now inside here we have a nut. We want to remove this nut, and there's a couple sleeves underneath it too, and we want to be really careful when we remove this nut that we don't lose those sleeves. So I usually take it off and then turn it underneath like that and pull it out. Now I want to pull these sleeves out of here because this is a big problem that people have, and this is where mistakes are made, because if these sleeves are not oriented correctly in this nut, when you go to put this on, it's going to leak air, and it's going to leak vacuum as well, and you won't get a good regeneration. So when you remove this, you're going to have the nut and what we call the shoulder sleeve, and then there's the cone-shaped locking split sleeve. You can see it's actually split. Now this particular sleeve is just there to make sure that this nut doesn't back off. This white shoulder sleeve is actually what does the sealing of the brine line. So I'm going to show you how these orient on the line when we push it through. You can see there's a hole here that comes through. You're going to push your brine line up through there and up through the actual brine well. Then we're going to put our nut on first. Then we're going to get our split cone-shaped ring, and we're going to make sure we have that cone facing the nut. You can see the taper's actually facing the nut. Then the shoulder sleeve goes on with the shoulder touching off on the cone. Just like that. Once that's done, we're going to install this into the elbow again. You want to push that in there until it's all the way in. And then we're going to push our nut down there, and we're going to tighten it hand tight. And then, like I said, don't be afraid to go ahead and snug it a little bit with the channel locks. Give it another half to full turn once you got it as tight as you can get it with your fingers. 99% of the problems with water softeners are right here in this brining system. Either one of these connections, or this brine safety valve is plugged, or the internal injectors are plugged. Most of the time, it's usually something to do with this line became loose because it wasn't snugged strong or tight enough in the first place. So that's the first thing you check when you don't have soft water. See where the water level is in here and make sure this line's tight. But like I said, on the installation, make sure you get it as tight as you can get it with your fingers, and then snug it at least another full turn with the channel locks. Another feature I want to talk about in here is there's an actual grid in the bottom of this brine tank. Smaller brine tanks are not going to have these. They're not necessary. But when you get to larger systems, you may see this grid in the bottom. That grid is just to isolate the salt away from the actual water that's going to go through this safety check valve. So if you don't have one, you're not intended to have one. If you have one, then so be it. Once this is installed and we have that tight, we can go ahead and put salt in this tank. And what I'd like to do is I'd like to bring the salt up to about where this nut is. That way it's never so high that we can't get this lid off and look down in there, or it's never so high that we can't take this safety valve out if we want, because every once in a while we may want to check that and make sure we don't have any kind of buildup or anything on it. But you're going to fill this tank up with salt, and then as the system uses salt, it's going to drop. And you want to wait until it drops down and you see water on top of the salt, and then refill it. The worst thing you can do is put a new bag of salt on once a week. You'll end up with a big chunk that won't dissolve. So it's a good idea to fill this up, use it all, fill it up. Now, once you've filled this up, we like to pour some water in here just to displace the actual check valve in the bottom, but also give us some initial water to use. To do that, we take this lid off, and then I would pour at least 5 to 6 gallons of water down inside this tube after you put the salt in. Don't pour the water on the salt because that tends to bond it together. Try to pour it in this tube. Now, if you get some water on the salt, no big deal, but try to pour the majority of your water in this tube. Once you've done that, you have your water in there, the salt's in there, then we're done with the brine tank, and now we can go to the startup procedure. Okay, to start up the valve, the first thing we're going to do is plug it into the outlet and power it up. This particular valve has what's called an SXT control. Now, we're still in bypass, the water's on, but we haven't actually introduced water to the tanks yet. So to introduce water into the tanks and to blow the air out, we want to put the valve in what's called the backwash position. So we're going to initiate a immediate regeneration, and once it gets to the backwash position, then we can actually start to let water in the tanks. So to initiate that regeneration process, we need to push and hold what's called the extra cycle button. This is the button all the way to the left that has a diamond shape made of arrows. Push and hold that. And you'll see it'll say BW and 4 dashes. That's what it'll say as the valve starts to turn. Once this says BW and then has a value here, which should be 10 minutes, then we can actually start letting water into the tank. So we're going to let this move around until we see 10 minutes on here and see it start to count down, and then we're going to actually start putting water in the tank. Once you're in the backwash position and the time is starting to count down, we're going to slowly introduce water to the tank. And when I say slowly, I mean we're just going to barely crack this valve open. If we put full pressure to this immediately, we could damage one of the inner distributor tubes or blow all the resin out of the drain. So we're going to slowly go in there, and you can tell when you go too fast because you'll hear a really large knock, and then you can just kind of back off. But in the backwash position, we're going to slowly feed water to it. And you'll hear the air come through here. Now, we've already pre-filled these tanks from a previous installation, so we're getting water a lot quicker than you will out there in the field. But you kind of want to just barely crack it open until you're getting solid water coming out of here. That way you know that you don't have a bunch of air and you're not forcing the water in too quickly. But over this backwash period, you're going to slowly open it up a little bit more and more until you get solid water with no air. You can see I'm still getting quite a bit of air here. And actually now we're getting a little bit of resin dust. to what's called the brine fill mode. Now, once we backwash it and we have the air out of it, we can push and release the extra cycle button to skip to the next cycles, because we're going to want to skip through the next two cycles, which is the brine draw and the rapid rinse, and then we're going to go to the brine fill. To do that, the main reason is we want to fill this brine line with water, so we want to make sure we don't have any air there. So to do that, again, like I said, once it's counting down in the next mode, which this is brine draw mode, it's counting down, then you just push and release this button, then it'll give you the next mode with the 4 dashes. And you got to wait until you actually see time on there before you start, or before you push the button. Otherwise, it won't do anything while it's actually moving. So got to wait until we see a time value show up there instead of the 4 dashes, and then we can push and release the button again. Now, during the brine fill mode, which is the last mode, it's going to push some water back into the tank, and we want to let that run for a minute just to push the air out of the brine line, like I said. So once we see that come to a time value, we're going to let that run for like 1.5 minutes or 2 minutes, and then we'll advance back to the service mode. So once in the brine fill mode, we'll let it run for 2 minutes. And once that's done, then we'll go ahead and push and release the button again. I'm not going to let it run for 2 minutes now just because I don't want to fill this brine tank full of water, but that would be the process. You would let it run for at least 2 or 3 minutes, push the button, and you'll notice now we just have 4 dashes with nothing. That means we're heading back to the service mode. Okay, now once in the service mode, you'll see it'll scroll from the time of day to the amount of gallons remaining between regenerations to whichever unit is online, tank 1 or tank 2. This tank 1 would be underneath the main valve, tank 2 would be under the ancillary valve. Now, when in the service mode, you'll notice that there's a spigot on here. Whenever that spigot is there, then you know you're in the service mode. If you happen to see this spigot flashing, that means it's going to regenerate that night if you do basically do a delayed regeneration. Now, whenever you go into a programming mode, this spigot will change to a pencil with 4 dots. That lets you know you're in an edit mode. One other thing that is on this screen is it'll actually show you that there's flow going through the system. So I want to show you that right now. As water goes through the system, you'll see this little drip blink. That lets you know that it's actually treating water going through the system. When that's blinking, you'll actually see your gallons remaining will slowly decrease. See, it went down to 81. This particular meter tool, it can also be used as a tool. If you know you have everything off in the house, but yet you see this line blinking, it could indicate a leak in your crawl space or possibly a dripping toilet tank or something like that. So those are a couple of the valve features. Now, to do the programming, to get to the actual master programming mode, we have to change the clock to 12:01 p.m. That's kind of like the unlock mechanism that gets us there so we can get to the master programming. So the first thing we're going to do is once we're back in the service mode and it's kind of scrolling through, we're going to push and hold the up or the down arrow, and that's going to allow us to change the time of day. So right now we know we have to go to 12:01 p.m. Now you can see a TD show up, and then there's the pencil with the 4 dots. So as you're going, you want to go up to 12:01 p.m. Now if you're on a 24-hour time cycle, there won't be a PM that'll show up next to the 1-minute digit. But if you are, then you'll see a PM. This particular valve is programmed on a 24-hour time cycle, so what you may consider to be military time. So 12:01, and then it's PM because it's military time. If you were on regular 12-hour cycles, then you would see a PM light up right here. So once you're at 12:01, then we hit the extra cycle button to save it. Now we can push and hold the up and down arrows at the same time, and we're going to hold them for like 3 to 5 seconds, and you'll see this screen change, and it'll tell you the display format. Now this particular unit is in liters, but we can also choose gallons as far as the format. This one's in liters because it's going overseas, but typically here in the States this will be set to gallons. So we're going to set it to gallons now just to make it easy for programming. Now once you have that set to gallons, the display format set to gallons, then you can push and release this button, which again acts kind of as the enter button or the save button. This next one is valve type VT, and this stands for downflow 1 backwash, and that's where you're going to want this particular type of valve set. There's some other options here, other UF filter, UF or just a filter period, and then there's downflow with 2 backwashes. None of those are options on a twin alternating system. The only option you want is DF1B. Do not change this to any other option other than DF1B. Once you're there, you can save this and go to the next parameter. Now, this stands for control type. This means, you know, do you want this to delay regeneration or do you want it to regenerate immediately? Being that this is a twin alternating system, we want it to regenerate immediately. So you'll see that we have FI here. So I standing for immediate. If it was delayed, it would say FD. Then there's also time clock, and then there's also days. But we're not going to do that for a twin alternating. Twin alternating will always be on FI for immediate regeneration. Push and release and go to the next one. This is just telling you that this particular system, the number of tanks is 2. There's 2 tanks. There's nothing to change here. That's just information, so we'll go to the next one. This is telling you TS, tank and service, which is U1. Again, this is just information, nothing to change here. So we'll push and release. And then this is called the capacity. Now, depending on the size of the system, depends on what you would set this at. There's a chart in the manual that will tell you. We're going to do about 25,000 for every cubic foot. So if you have a cube and a half, then you'd cut that in half and put that at 37,000. So these particular tanks that we're on are 1 cubic foot, so we're just going to put this up to 25. But there's an actual chart that you're going to follow in the manual to tell you what to set this to depending on the size of your unit. But this one being a 1 cubic foot, we're going to set it to 25, which is 25 times 1,000. That would make it a 25,000 grain per tank. We're talking about per tank here too, so 25 per tank. We're going to save that and go to the next parameter, which is hardness. Now, the hardness level is going to be site specific. That's something that you're going to have to know. You're either going to have to get that from your municipality, or you're going to have to get it tested and get a level that way. But the value we're looking for should be in grains per gallon. If you have a hardness level that comes in parts per million or milligrams per liter, then you're going to want to convert that to grains per gallon. And you can do that by dividing that number by 17.1, and that'll convert that ppm or mgl to grains per gallon, GPG. So we're going to say that this particular application, the hardness level is 20, so we're going to take that down to 20. Now, it's never a bad idea to put a cushion in there just in case there's some fluctuation in your hardness level of the feed water. I usually put at least a 3 to 5 fluctuation, so actually we're going to go back up to 25 here if our hardness was actually 20, and that would be our hardness level. Now, if you're using this system to remove iron too, then hopefully it's not much more than 1 part per million or 2 parts per million of iron, and if you are using it for that, be sure to add that when you're doing your hardness level. Basically, whatever your hardness, or I mean your iron level is, you're going to multiply that by 4. So if your iron level is 2, we multiply by 4, which is 8, then we would add 8 additional grains to this just to compensate for that iron treatment. So once we have the hardness programmed, we're going to go ahead and save that and go to the next parameter, which is the reserve selection. Now, if you're in a situation where this thing is going to run several times during the day, then you may want to put a value here. But for the most part, that's not even necessary because this is a twin alternating system that's going to kind of switch over when it needs to. So it really, there's no benefit to do that. If you want to do it, I suggest that you use the RC function, which is on there now. and you can actually choose how many gallons you want to put in reserve capacity. I can't remember what it goes to. I think it goes to a couple hundred or something, but for the most part, I never do anything with this. If it's a specific application that you want to do that, you can, but being a twin alternating system, it's kind of a defeating the purpose. You really don't need to do it. So we're going to go past that, and then we're going to see DO. This is a daily override. So let's say this system didn't regenerate for 14 days. The override would kick in at 14 days and cause it to regenerate. I would say that if you're buying a twin alternating system, there's a good chance that you're never going to hit that daily override, and that's why you need a twin alternating system. But if you want to leave it there for like vacation purposes, something like that, where you're gone for a couple weeks, then you may want to switch this down to like 10 days, so that way after you've been gone for 10 days, this will regenerate before you get back and be fresh. Once we have the daily override set, we'll enter, save that, and go to the next one. Now this is the regeneration time, which really means nothing on a twin alternating system because it's going to regenerate basically whenever it loses its gallons or uses the gallons and it's at its capacity. However, if you do what's called a delayed regeneration for this to regenerate at your specified regeneration time, then that's when this time would matter. So if you want this to regenerate tonight after you go to bed, you would leave it at 2 a.m. and then let it regenerate. Basically, by pushing and releasing this button, that triggers that delayed regeneration, which would be 2 a.m. So I just leave it there at 2 a.m. That's usually a good time when people are in bed. If you're working night shift, then you might change that to another time, just as long as it's a couple hours after you go to bed. Then we're going to go to the next parameter, which is backwash. The backwash should backwash for 10 minutes. That means it's going to lift this tank and backwash for 10 full minutes. The next one is the brine draw, and that's when it's actually pulling salt solution in from the brine tank. We do this for 60 minutes. Now, the salt solution will probably be empty somewhere around 10 to 15 minutes, but for that remaining 40 minutes or so, we want to slowly push water through there and push that salt solution out. Retention time of that salt solution through the resin bed ensures a really good regeneration. So, just because the water is out of the brine tank doesn't mean that you should shorten this cycle. We want this cycle to stay 60 minutes so it pushes that brine through the resin bed really slow. The next parameter will be the rapid rinse. That typically is set to 10. This one's set to 12 because it's for a larger unit. You're going to basically leave that there. That's going to be factory set. Now, once you've went to this, you save that rapid rinse, go to the brine fill. The brine fill is what really is most important. And again, you're going to use the chart to actually set this particular parameter. We're saying that this is a 1 cubic foot unit, so for 1 cubic foot, we like to use 10 pounds of salt. Now, we can get about 3 pounds of salt in every gallon of water. So basically, to get 10 pounds of salt dosage, we need about 3.5 gallons of water. This particular unit will fill the brine tank at a half gallon per minute. So if we need 3.5 gallons, then that means we need to run in this mode for 7 minutes. So we would change this to 7. Now, you can use the chart, and the chart will tell you, and sometimes it'll bump up 1 minute higher or lower just to make sure we get a good salt dosage. But the chart will tell you what you need to put in based on the size of your system and what area you're in, what medium or high salt curve you're in. Once you have that set, then you're going to push and release the button and go to the final parameter, which is the flow meter. That's what FM stands for. Now, this particular one, like I said before, is a turbine 3/4 inch meter. So it's a really crude T, but that's supposed to be like an old typewriter lowercase t, and then 0.7, which would, if we had another digit, would be 0.75 for 3/4. So for this particular unit, we would do T 0.7. If it was a 1 inch, then it may say P's 1.0, or it might say T 1.0. An inch and a half would be T 1.5 or P 1.5. Any of those would be acceptable depending on which size system you have. This one right here, like I said, has the 3/4 inch meter, so we're going to use T0.7. Now once you're done, you're going to push and release that button, that extra cycle button, and that saves everything we've done. Now the unit's programmed and it's ready to treat. The only thing that you would need to do now is to actually set the time of day to your actual time of day instead of 12:01. So depending on where you're at, you're going to push and hold this up arrow and change the time. Here it's 12:45, so we're going to take it up to 12:45. And then once you change the time, push and release the extra cycle button, and you're pretty much ready to go. Now you can actually put your cover on the front of the unit. And it just pops on here. And there's a couple screws on each side that hold it on. And that completes the installation.